Hello students, welcome to today's session on center of mass from the unit of system of particles and rotational motion. Okay, so this is one of the most crucial and most sensitive topics, and the topic in which 70% of the CBSE students face difficulty because center of mass is something which gives them goosebumps. Yeah. So what do you mean by center of mass? It's basically the centralized point of that. If it is that concentrated point on present on the body of any mass on which the mass is getting contained, or it is the central point from which it will shift its equilibrium or inertia. Okay, that's the center of mass. It can lie outside the body also. Okay, inside the body, on the body, and outside the body. That is one of the most crucial facts of center of mass. Yes. So let us consider a collection of n particles. Like if there is a symmetric substance, like you can consider this to be a symmetric substance. This is a sphere with mass m. So this point will be your center of mass. We can say that the center of this sphere, center of sphere is marking the center of mass of this body. Let this body be A. And let the mass of ith particle be mi. Okay. So what are we doing? We are actually considering a collection of n particles, We don't know how many particles, but there are n particles. Let the mass of ith particle, that means this particle is taken to be the ith, is denoting us to be mi. That's the mass. And the coordinates with reference to the chosen axes are xi, yi, and zi. We are writing the product of mi, xi for each of the particles and then giving them a summation. So summation comes out to be the resultant of mi, xi. Similarly, we are going for the y-axis and then for the z-axis, respectively. Okay. So x, that means the net x will be 1 by m, summation of mi, xi, and y will be 1 by m, summation of mi, yi. Whereas z will be 1 by m, summation of mi, zi. So these three this is the pattern to write basically the center of masses. And we are locating the points with coordinates x, y, and z. X, y, and z axes, we are locating the points. This particular point allocation is known as the center of mass of the given system, given collection of the particles. Whereas if the position vector, of the ith particle is Ri, the center of mass is defined as to be the position vector itself. That is, position vector Cm is equals to 1 by m summation of mi, Ri. And this is also one of the most important expression which students need to practice. Our Cm is equals to 1 by m summation of mi, Ri. That's it. Let us perform one of the questions of a block pulley system, and we can consider the acceleration of the center of mass. Okay. How to consider the acceleration? We all know, we all can write certain equations. The equations which can come out to be m2g minus m1g is equals to m1 plus m2 times a. Whereas the acceleration of the center of mass is becoming m1 a1 m2 a2 upon m1 plus m2. What have I done? I have actually subtracted force is equals to ma of the two particular block systems. The block which is having heavier mass is having the downward gradient of acceleration more than as in compared to the mass which is relatively higher to that particular mass on the very same spectrum of the pulley system. Yeah. Acceleration of the center of mass becomes M1A1 plus M2A2 upon M1 plus M2. Now, what are we doing? We're substituting the values. We know the values. M1, M2, sorry, minus M1 upon M1 plus M2 times M2 minus M1 upon M1 plus M2 times G. And this derivation has been performed in the previous classes. So one must join the sessions to actually learn of the key derivations, which are very much important. So derivations means concepts and concepts means understanding, which is standing out here to be at utmost priority. We can square both the brackets and we can write it as M2 minus M1 upon M1 plus M2 times square G. Your acceleration becomes M2A minus M1A upon M2 plus M1, where A is also being written to be as G. That will be our answer, where M2 was heavier than M1. Yeah. So certain more examples will be practicing in my upcoming session. So yes, I hope you students all understood the topic very well, and keep practicing, students. I'll be connecting you in my next class. And if you possess any doubts or queries, please revert to my Urban Pro profile. Thank you so much.